Okay, so next presentation's from Mohammed Khan at Rocklabs. It's the future of automated sample preparation. So Mohammed is an experienced mechanical engineer specialising in global mining, laboratory automation, currently working as a business development manager for Rocklabs. Please welcome Mohammed to the stage, everybody.
Hello, everyone, and thank you for the introduction. And again, appreciate the opportunity to speak at this event. And so far, it's been an absolute great event in terms of just getting to know a few people here. I know it's only kind of been half day, but I think there's been definitely some interesting topics come up. Now, I'm kind of glad that this presentation that I'm doing is after Rob, because now I don't have to explain the importance of sample preparation. I think you've done a great job there, so thank you for doing 50% of my job. But what made me think as I was listening to the presentation that Rob just did was we've always talked about sample preparation labs, and it's about making decisions, right? Like that has been kind of the core. But there is something that a customer said to me, so I can't take credit for this saying, but it really stuck with me. And he said to me, it's about turning dirt into data. And I think that was definitely something that if you are to explain sample preparation, labs, analysis, everything, what are you trying to do? You're trying to turn dirt into data. And I really think that's definitely been kind of the key messaging that's been coming around. Now, can I get a show of hands? Who's actually ever seen the company Rocklabs or even used some of our equipment? Oh, look at that. So there's only a few people that I'm going to have to go around and convert into Rocklabs. So that's great. Now, in terms of just a quick introduction to Rocklabs, Rocklabs has been around since about 1969. Up on the screen there is our founder, Ian Devereux. He started the company based out of New Zealand. Interesting enough, we are a company that was started in New Zealand. We design, manufacture, and produce in New Zealand and export 99% of our stuff. New Zealand's landscape of mining is starting to grow slowly, but there is not much mining in New Zealand. But we are still based and we still operate out of there. We were purchased in 2008 or acquired by a company called Scott Automation and Robotics, hence why you'll see the name Scott attached to a lot of our branding as well. This is our facility or our factory in Auckland at the moment. So we've just moved into this facility about 2 years ago as we've grown and scaled up in size. At the moment, we do have 18 agents around the world as well as our direct presence, and we are supporting over 100 countries all over the world as well. In terms of a product portfolio, we have the crushers, the pulverizers, splitters. We do mining automation, which I'm very happy to talk to you guys about today, as well as CRMs as well. So if anyone is interested in talking to CRMs, I'm not the guy, but I will pass you on to whoever needs to talk about CRMs as well. This is just a map of the representation from direct presence to where we also have agents. As you can see, it's an absolute global scale which we operate on as well. Again, we have been around in the sample preparation game for many, many years. We did have a white paper written by Richard Minnitt highlighting what our equipment is capable of and also the accuracy of our splitting devices, so what we call our LSDs, so our linear splitting devices. Happy to share the white paper around so you can have a read of it post this event, and then anyone can, if you have any questions as well. Cool. All right, so the future of sample prep. Everybody knows that sample preparation is one of those jobs that is so critical, but it is also one of the most labor intensive jobs. Nobody wants to do it. As Rob was saying, that sample preparation guys will typically move on and go into another sort of industry very quickly, or just trying to find people that want to work in remote places is very difficult. Now, we are no stranger to sample automation. We've been doing sample automation for many years. This here is just a loop of a video that we did for a company out in South America, which actually included some fire assay work as well. Now, what we have done in the past is sample automation has always been sorry, how should I word this? Has been treated as a project. So everything's been very bespoke. Everything was client driven, but as everybody knows, sample preparation is very uniform. You have to be repeatable, you have to be able to do it over and over again. So though every client has slightly different needs, they all need to stick to the same repeatability, the way they do everything, and also the fact that you need to be able to maintain these systems as well, because as soon as these systems go down, your whole lab may end up going down as well. Now, during the time of COVID and when the world kind of came to a halt, we did have a lot of feedback from the market surrounding these sample automation pieces of equipment. As you can imagine, trying to mobilize our teams to go maintain these equipment, trying to get people not even just internationally, but also just the fact that we couldn't move people from Australia to another state was very, very difficult, which made us think, what are we trying to do with automation? Are we over-engineering? Is automation actually turning into a bit of a hindrance to this? Or are we actually creating value for the customer? So with that, we went back to the drawing board to understand what we do well, what we actually understand how to do, and where automation is actually needed. So this next slide here, which was a bit of feedback that we got from the market. Now, interesting enough, the things that Rob said in terms of what goes wrong inside of a lab was very much the same things that were repeated by our customers. They said to us that remote areas, very hard to access, specialty maintenance, ongoing spares, skilled operators, trying to find them in the first place, then trying to train them, and then also trying to retain them as well. We've had many comments in different regions of the world where sample prep people will tell us that they'd rather go flip burgers at McDonald's because it pays just as much than me trying to do manual labor. So interesting enough, you get all this feedback, but the biggest one that was highlighted was the actual maintenance of the automation. It is a very, very specialized. You almost have to have an engineering degree to be able to maintain these things sometimes, which does mean that your maintenance teams, your shutdowns all have to be on point. Now, I think someone did say that the lab guys also say the maintenance teams don't even come down to the labs. So that is definitely a true piece of feedback that we got. So when we went back to the drawing board, when we went back to the drawing board, we thought, well, what do we know we do well? We know how to crush rock down to 2 millimeters. The Boyds do it day in, day out. We know how to pulverize. We can pulverize it down most materials down to 75 micron, and we can do that very, very well. And we know how to split. So we can do that with an RSD, we can do that with an LSD. We know how to do those three things very well. Then we started looking at, well, what have we actually used to automate? And we started looking at the robotic arms. Now, typically in most robotic sample preparation systems, you'll see a robot circle, you'll see a whole bunch of the robot in the middle, and you'll see a whole bunch of modules around it. And most typically they use industrial robots. So industrial robots are the big ABB Cougar robots that kind of found in foundries, they're kind of found in car manufacturing. And let's be honest, they're kind of overkill for what we're doing. All we're doing is picking up 10 kilos, tipping it, and then doing that over and over again. So we went out to the market to understand, is there a better way to do this? Is there another way or another technology that could do this sort of automation that is simpler? Because we're not making high-end decisions in terms of the actual process. We are trying to get the data out of this, but the actual process of picking up and tipping isn't a very complicated piece of process. And when we went out to the market, that's when we saw that there is a technology out there called cobots. Now, cobots are a very, very modular, simple robotic arm. They are great for actually working alongside humans. Now, there are a number of production lines out there, Caterpillar, Toyota, some bakeries as well. that they have these robotic arms standing next to people and they work with them and do these kind of repeat mundane tasks. So we started thinking, can we actually apply this to sample prep? Will it work? I mean, everyone's been to a mine site, very dusty, very dirty, and at the end of the day, that dust, dirt will basically kill any sort of robotics you have. So we started doing a lot of research into this, and we bought a few of these cobots, brought them into our factory, and just ran them day in, day out, threw a whole bunch of iron ore onto them. I don't know if anyone's actually worked with iron ore here, probably has, but it's super abrasive. Once it gets into some of your joints, it's like basically taking sandpaper and you won't, yeah, there's things that we've seen where we're just like, wow, we didn't even think of that. But as we worked with the cobots, we did start seeing that these things are capable. But what we also wanted to make sure is that if something does go wrong, because this is where the main concern was with automation, if something does go wrong, what do you actually do? You can't just rely on a tech to come out to fix this. How do you make it so that your operators or your own site can actually look after this themselves? And this is the beauty we found with the cobots. The cobots are actually interchangeable. So you can actually have a spare cobot sitting on the shelf. Something goes wrong with a cobot, you can actually take it out, plop another one in, and the cobot can get then sent away to have looked at, or a technician can come do whatever they want. But your lab doesn't go down for it. So this was one of the biggest revolutions we kind of looked at was, well, we can actually swap these things out. The next slide I'm going to show you is what we would like to introduce to you as our AMS prep line. Now, the word AMS stands for Automated Modular Solutions. And how we've gone about this is we've built this automated ecosystems based on different modules. What this is a series of solutions we can offer that will allow you to do different activities and different combinations, but using that same methodology that I've just mentioned around with the cobots, where things are swappable and things are rotatable, and then the maintenance for this is very, very simple. What you see in front of you is 3 modules that we have, which will do your sample prep. You have your crush cell, you have your pulverized cell, and you have your dispensing cell. The naming conventions are very simple. Marketing was very easy on this one. But what we really wanted to do was we really didn't want to reinvent the wheel. So inside of this, it uses our Boyd crushers. So again, reliability in terms of getting down to 2 millimeters repeatably. The next module uses our standard mills. So Rob, I think you mentioned LM2s before. I think that might have been the problem, not the actual. But this does use our mills, which we know again can mill down to that 75 micron on some certain materials. And then we have our dispensing cells, which they use our LSDs to split or do the final split of samples ready for analysis. Now, why AMS? Like, why would you do this? Why would you go to an AMS over, manual equipment? It's pretty obvious around the manual and people aspect, but there is a whole bunch of hidden costs that people don't even think about, and I think that this is starting to come out, especially today, around when samples don't report the data they're meant to be reporting, that you don't realize till 2-3 weeks later, sometimes when it's even too late. This system that we have designed is actually started in 2021, so we've been doing a few years worth of just pure R&D. So this is not something that has just been a project that we've pushed out to the market. We've actually turned it into a product. It is modular, so we are able to add on modules rather than just saying, hey, here's a solution, and then 3 years down the line when you're like, hey, I want to do some upgrades, it's not a rip it out and start again sort of situation. It is modular, so you can add on things as technology progresses, as the market changes, and I'll show what I mean by that in the next couple of slides. Footprint, now it's got because it's of a linear design, the footprint is very compact. So if you are wanting, or as most brownfield sites are, you're already constrained for space, so you don't want to knock down walls. It does actually have a very compact footprint as well. And probably one of the main things is that it is actually scalable. So if you are wanting to increase throughput, it isn't just a matter of this is the capacity, this is all we can do, and then you guys have to work for 24 hours to try get your throughput. You can actually add on systems as well to this to make it scalable. But the last point there, and this is probably one of the biggest points, is that we do have a proof of concept. And what I mean by proof of concept is that we have actually built a prototype which lives in our factory in New Zealand. We've invested in it, it will stay there, and it will be used for sample testing prior to any sort of agreement or prior to any sort of commitment to purchase the system. And the reason why we've done that is that we've had a lot of learnings from sampling, that you could take a sample from the ground here, and that sample will behave slightly differently from the sample that's taken over there. And then as soon as you hit a water table over there, it's a completely different thing altogether. So that proof of concept and that prototype that we have in Auckland is open for customers to send sample over. You can also come to New Zealand as well. It's a great place. And you can also see the system itself and actually understand what it will do, rather than seeing most of these projects like they are on paper, before you actually commit to a system like this. Now, I know this is highlighting challenges again, and a lot of these challenges have been highlighted by basically almost all of these presentations that we've talked to so far. But it comes back to the same sort of 5. A lot of people ask me, what are the main challenges you have, especially not just with automation, but also just sample prep in general. And health and safety foremost. Volume flexibility. You're going to have, maybe 200 samples, but then that might ramp up to 300 samples and then drop off. So it might go up and down. Labor shortages, mix of products. So what I mean by that is, especially in a commercial lab, you could be doing different commodities, but if you are on-site labs, you could still be doing different sites, different areas, or even you could go from chips to cores, etc., etc. And then space limitations. Everybody knows that we're fighting for real estate, and the lab ends up being the last person that actually ends up getting a bit of space. This is why the proof of concept is so, so important. You get a full understanding of what you're going to get up front. And this is also why we've really invested to make sure that the fact that, and to Rob's point, is that when you don't have enough information up front to when you do your lab design, 9 times out of 10, the lab's not going to deliver what you actually intended to do. Now, this is just a study that I found, but I found it very, very interesting. It's not mining specific, but what this study did was McKinsey & Co., they did a study in terms of capital projects. And when they meant capital projects, just any project that was sort of bespoke. And they showed that if you have access to a proof of concept, that 40% of the time that project will actually go ahead. A lot of executives rely on the proof of concept to even make a decision. No one wants to be the guinea pig, especially in the lab space. You produce the wrong data, that you're kind of going to be up for it. And this was resonated through both, not just McKinsey & Co., the PMI, and then also Deloitte. It just shows that with the proof of concept, how much easier it is to actually get a project across the line. And this is not even just actual completion of a project, this is actually starting the project in the first place. Now, I've seen many labs who have a lot of people, lab managers that come, and they all have these great ideas how to improve the lab. But again, it's the implementation side where the business might say, well, can you guarantee that's going to work? Or if you're going to spend this much money, what guarantees do we have in place that this is actually going to make an impact on the site itself?
I've worked pretty closely with a number of automation setups. And a lot of things, in principle, they all work okay. And what's different often is the software. So on a mine site or in a lab in a town site where these things go into place, the person who's often very key to that is who knows about the software. And if it goes down, you need that software person there to fix it. What are your Rocklabs going to be doing about the software? Is it a fairly commonly understood software, or is it an in-house private information system that we don't have access to?
So in terms of the software itself, it is written in-house. So it is a in-house thing that we have done. And I knew the software question is going to come up, obviously coming to a function conference from Datamine, but we have allowed access to the software. So at the moment, the system as it's set up is able to export out all the data. So everything it collects will export out in a basic CSV file. Now CSV is probably the most flexible to go into another LIMS system. This is where we are kind of knowing, what we're good at, so staying in our lane sort of thing, where we allow all that access and we allow all the data to come out from the system itself. Hence, from there, we get our clients to engage someone like Datamine or someone else to do the integration into the actual LIMS system itself.
Just more a reinforcement comment. So there's a saying in the software industry about proof of concepts that if you don't do a POC and throw it away and then build your final, you'll be shipping a POC to your customer as your first release with all the bugs as such in it. So having a POC strategy is a very, very robust commercial strategy in the software industry as well.
So just a brief overview of what this AMS system looks like is, first and foremost, the interaction an operator would be with our sample registration desk. Now, this is kind of the command center. What we've done with this and understanding how labs operate is that this registration console can actually be placed around the lab. It doesn't have to be next to the system. We understand that there's entry points, we understand there's ovens, so it can actually be placed in and around the actual lab itself. And what it consists of is you have your HMI screens, you've got a balance, you've got a extraction backdraft built into the actual unit itself. But the biggest thing here is that we have also introduced RFID tracking, and this is where the system will be able to track your data that goes through the system, so your sample, via RFID. So when a sample registration happens, you can input it via your HMI, you can input it via your barcode, and that will be transferred onto a RFID tag which is attached to the trays during the registration process. Once a tray is registered, it will be loaded onto a trolley. Now, our trolley has capacity for 21 samples at a time. You can register multiple trolleys at once, so you can have a few of them going. But the sample with the system will be able to accept a trolley at a time. The first interaction the sample will have with the actual system is with the crush module. Now, the crush module itself consists of a cobot, and it also consists of our Boyd crusher paired with an LSD. So what this will be able to do is we would be able to take a sample, and it's just got an example there of 5 kilos, and it will be able to then crush that sample down from your top size of, let's say, 80 millimeters down to 2 millimeters, and then be able to split it into a predefined recipe. So that was one of the beauties of the actual AMS system as well, is that we can set up recipes for different sorts of samples, but we also leave that open as well, because we know you get samples that are random all the time. So sometimes you have to set up your own, but we've left that flexibility to be able to adjust that as needed. So this will then take that sample, crush it down, split it, and also be able to retain any waste if you like as well, depending on the site itself. We understand that sometimes you have to retain all your waste for QA, QC, crush checks, etc. So if you put all your sample through, you can actually retain some of the waste that comes through from there as well. Once it's gone through the crush cell, it will then be dispensed into what we like to call ABM cups, but what they basically are cylindrical cups, which are on the right there. Those cups also contain RFID tags, so the data that's been transferred from the trays that originally came in have been now transferred to those cups, and those cups will then go into the pulverizing cell. That pulverizing cell actually contains two mills, and those 2 mils will be able to pulverize the sample down to your 75 micron or whatever your requirements are. Once pulverized, it will then discharge the sample and head over to the dispensing module. Dispensing module is the final module for the prep line, and what this module does is that it will take that pulp and then split it down into a vial. So it will then be able to be passed on to your analysis. It will also be able to print onto your vial, as well as have RFID stickers that we can put onto the vial as well. So you do have some redundancies in terms of if your barcode rubs off for whatever reason, or vice versa. If your RFID tag does fail, you can have a physical print on the actual vial itself as well. So now we've gone for a sample that's come in, it's been crushed, pulverized, placed into a vial, and it's ready for the analytical end. Now, just talking in terms of the future photon assay, I know that depending on who you talk to, fire assay is going to stick around forever, which is probably true, but it is an emerging technology as well. So we have also made this adaptable as well, just because we understand that there is changes coming in the future. How long that is, not sure, but we just need to make sure we are ready for it. So the next configuration I'm just going to show you is a configuration that we can offer as well, where it is just a crushed cell. So because photon assay only needs a requirement of 2 to 3 millimeter size and filled into a photon assay jar, it can be a solution that we can offer. So then you can actually pair this right to your photon assay machine as well. So this just goes to show that there are things that we can do because we've done it in such a modular fashion that every time something changes, it is just a module that needs to be changed out. Thinking forward as well is that along with the direct filling of the photon assay jars, we also thought about lidding on top of the jars as well. Now, this is a very interesting thought that we had because, as Spade mentioned earlier, that someone had to go and stamp a whole bunch of bags. Imagine putting automation into a lab and now someone has to stand there and screw lids on all day. So this just goes to show why we are really using that proof of concept and that prototype we have to develop the system to offer a solution that actually really works. As there's no point in pushing something out that when you get to site, there's all these kind of hidden inefficiencies. Now, we do also have, and again, because this is a ecosystem, we do also have add-on modules which sit outside of the prep line. The next module that we have developed is a dosing and fluxing module. Now, I know Fluxman over there is going to be really happy about this. But this here is actually a system that is based on another system we did back in 2013 in Nevada, where it was dosing test tubes. So we've had a lot of lessons learned from that. And what this system can do is it can take the vials which have come out of the AMS prep line. A operator can then load it into this system, and this system can prepare crucibles ready for XRF and also a TGA as well. But we do have its adaptability to go into the kind of fire assay space, etc., if required as well. But we did do a lot of development to make sure that the crucibles are prepared, they're repeatable, and it just follows the same methodologies that we have with the other modules as well. Following on with that, we do also have what we call the bead fusion module. The bead fusion module is the next step in the analytical space if you are doing XRF. So this will take a tray of crucibles which have come off the last module. It will be loaded into this cell, and this cell will then run it through an XRF, or first it'll turn into a glass bead, and from that glass bead it'll run it through an XRF machine. Currently, the setup you see is one we did with Melvin Panalytical's gear as a partnership, but that doesn't mean that we can't use other analytical equipment as well because of the system being so modular. If you are using the likes of like a Rigaku or someone else, we can actually drop in different modules into the system where we'll do the integration, and the analytical will happen from the experts in that industry or that side. Now, this slide here just goes to show something that is being reinforced over and over, especially in the lab space. And this is just feedback that we get all the time, is why go to automation? And it's just a representation. If you were to do 16 samples per hour, and let's say your work day is a 22-hour period, so 2 shifts or whatever it may be, you'd end up doing 350 samples a day sort of thing. With manual equipment, you can tell me an operator is really, really good and they're going to tell you that they can do 10 samples an hour. Yeah, probably at 9 a.m. in the morning. But by the time you get around to 4 p.m. and they're lifting 20 kilos into a crusher, they're going to slow down. So typically we see that to do 16 samples an hour with standard equipment, you need 6 operators. With semi-automated equipment, which we also do as well, where we have batch mills, etc., that drops down to about 3 people. With the AMS, you literally only need a operator to be able to do this. All they have to do is load and unload the system itself. So it just goes to show how you can actually free up your operators. And if you are looking at increasing throughput and you scale the system into 2 or 3, you can have one operator looking after more than one system itself as well. I'm just going to skip the next slide. I think it's a repeat. But what I would also like to show is that we have gone from proof of concept, and again, we've heavily invested in the proof of concept, which will stay with us basically forever. But we've also done real life applications now as well. So Mineral Resources have now fully commissioned a system from us in February of this year. So that included 2 full AMS prep lines, 2 ADF modules and 2 BFC modules, and that is fully hands-off and operating by Mineral Resources from February of this year. Kinross Gold over in Alaska, we have just commissioned our system in factory, and that is going to be shipped over to them and is going to be heading over to that side of the world towards basically the end of this year. We have also had sample tested on our prototype site from Freeport Copper, as well as Intertech as well. And we are just building a portfolio of samples and how samples behave through our prototype. So then that way we also have a knowledge base of what these samples do as well. Now, just a side note, it was very interesting. When Mineral Resources did their commissioning, you can imagine it was in WA, it was during summer, inside of the shed. Outside it was about 45 degrees, inside the shed it was 50 degrees, and it really did the strain test on our system. Now we've gone the opposite and gone to Alaska, so this is going to be very interesting, where it's going to be negative 30 degrees, and seeing how that acts as well. But again, with that proof of concept, we were able to do some demonstrations and some tests in-house to understand what it will do, barring there are some limitations of what we can actually do before it gets outside of those thresholds as well. Now, there is a short clip I'll show you of our proof of concept and the system that we have in the Auckland site. Why I really like showing that video is to highlight those cobots. Now, this video just really shows how small they are when you compare it to a robotic arm. Kind of weirdly, you can almost call them cute. But it just goes to show what is fit for purpose, right? Like, we have historically been using industrial robots for something that, again, they were just well over engineered for the actual the process they needed to perform. And it just, again, looking at the reliability side of it as well, is that maintaining something that is kind of over-engineered, really looks at automation in a dark light as well. Now, going to the maintainability side of this and really understanding that we are wanting to make the AMS ecosystem not just a project, this is actually a product. And what really defines you as a product? You have the product itself, being a product, the spares, the service, and then the documentation or the maintenance procedures behind it as well, which will really define you as a product. Now, where we looked at the design of the AMS, we gave ourselves a target. Any single point of failure that we can identify that would cause the system to go down needs to be swapped out within 2 hours. So that included the cobots, that included the crushers, that included the pulverizers, that included the splitters. And what we do is that as part of the system, we supply a package, what we call rotable spares, and those rotable spares will be sitting on standby. If for whatever reason the system is to go down, that can be swapped out as in a complete assembly, and then we can come out or it can be sent back for the maintenance that it's required. We did a test in our prototype, and this is, again, I know I keep touching on this prototype, but this is why it's great to have this prototype, where we got our apprentices who are training to see if they are able to swap these things out within that 2 hour window. And yes, they were able to do it after we did a little bit of optimization in the design of how the assemblies are pulled out. Now, I think with the service and maintenance, everybody here has a awareness of the challenges, and probably the biggest challenge is just access to maintenance techs, where on a mine site, the labs do kind of get forgotten about because there are really, really big systems out in the plant where the maintenance guys are just occupied with as well. So this is why going back to that rotable spares methodology really, really helps. But what it allows us to do is also build a service support for the actual client itself, knowing what capabilities that site has. So what this means is that we can have a site that has full capabilities and maybe just needs us for kind of preventative maintenance every now and then. We can build a service program around that. Or it could be on the flip side where the site doesn't actually have maintenance to tech. We can provide operator training to be able to do it themselves, or we can look after it from an OEM perspective and just do it that way as well. So this really then turns the bespoke project of automation into an actual product, because then we are able to do service and have service programs for the actual system itself as well. That brings me to the end of the presentation.
Thanks, Mohammed.
Yep. Thank you.